I would like to now introduce our speaker for today. Deb Freiman is co-leader of the Kalamazoo chapter of Citizens Climate Lobby, that we always just say CCL, but in case people didn't know what that was, and a member of the League of Women's Voters of the Kalamazoo Area and their Climate Change, Environmental Justice and Biodiversity Committee. Today, she learned about En-ROADS at a CCL International online meeting in July of 2017 when the climate simulator was being tested around the world. Deb and other CCL members were part of the first training. Since then, she has introduced this tool to various organizations around Kalamazoo. Updates are released almost monthly, and she has continued to take refresher courses. Developed by Climate Interactive, the MIT Sloan Sustainability Initiative, and the Ventana Systems, En-ROADS is a system dynamic model carefully grounded in the best available science and has been calibrated against a wide range of existing integrated assessment, climate, and energy models. It's a tool for everyone and a great tool for having climate conversations because it uses the best available science and leaves participants with a clear understanding of the magnitude of the climate crisis and what needs to be done about it. And now I will turn it over to Deb, who will give us the demonstration and knowledge on En-ROADS.
Sure. Just a little more background for everyone when we talk about using the best available science. The sources are really varied, and they've tested all of the information that they've built in to the model against different models that model systems. But the spectacular thing about this thing is it operates within a fraction of a second and gives us instantaneous information about the climate solutions that we're proposing and the impacts that that will have on other systems, as well as on the increase in temperature across the world. It is a global model, and so we're not able to test solutions specifically for Kalamazoo or Michigan or even the US. But when we all work together, we can figure these things out. And En-ROADS has presented at COP28 and lots of other COP meetings to the actual leaders of COP, and they always show up. And when the solution comes in after COP, they analyze that. And so they're able to always tell us what COP has proposed isn't quite enough to get us to where we need to be. And so the data sources that they're using are from places like the International Energy Agency and the Intergovernmental Panel on Climate Change. And so you can trust that the information is quite current and quite reliable. They aren't able to model every single thing. And this really isn't a prediction for the future. What it is a tool for us to use to have conversations with other people about climate change. And I really hope that each of you who haven't used it before will take the step to talk with other people that you know about solutions to climate change and test them against this tool to find the way that you think things should be done, and then to advocate for those. And another powerful thing about the tool is that if anyone disagrees with any of the parameters that have been built in, everything is open, and you can actually change most of the assumptions. And so with that, I will share my screen and we'll open up the simulator. When you log on to En-ROADS, you're going to come on to a screen like this. This just explains a tiny bit about the tool before you get into it. And En-ROADS has been modified so that it doesn't have to be just a workshop like this today. It can also be a role-playing game or an assignment for students. And so there's lots of options there. So this is the tool. And what you're looking at is in the top left-hand corner here. I've got this little red circle around my cursor so you can see where I'm going here. We've got the global sources of primary energy. And if you're on a small screen, you may not be able to see this, but in brown, we've got coal, red is oil, blue is gas, green is renewables, pink is bioenergy. There's a little teeny tiny line up here for nuclear. Nuclear really doesn't play a big part in the global primary energy mix. And then down here, you'll see there's a new orange area that isn't showing up on the global sources of primary energy yet. But En-ROADS has factored in the fact that there are a lot of new energy sources that are being tested. And we believe that some of those will become viable over the future and could be a game changer at some point in the future. I will also say that En-ROADS stands for, it's an acronym for Energy, Rapid Overview, and Decision Support. So it was really created so that people could have conversations not just with your friends and family, but with legislators. And this has been introduced, like I said, at COP meetings and also to legislators here in the United States to help them test the effectiveness of solutions that they're working on. So with that, other than the global primary energy over on this side, this graph is now showing the greenhouse gas net emissions. So this graph is starting at 2000, the year 2000. And this line is showing us, there's actually two lines there. The black line is a baseline. The current scenario of where we are headed for temperature rise. When those of us who trained back 5 years ago first looked at this, the number that we were seeing for temperature rise over here on the right was 4.2. Because En-ROADS updates all the time, that number has gone down from 4.2 to 3.3 based on the things that have been implemented across the world already. So there's hope in this model. I'm really hoping that you all come away from this with a good understanding that there is hope that we can still make it to a less than 2 degree future. So this bottom half here shows various levers grouped into energy supply, transport, land, food, and industry emissions in those columns. And then down here on the bottom, carbon removal, buildings and industry, and growth. So these are the solutions that En-ROADS has given us, the tools that we can test. And so what I'd like to ask is if there's somebody who will unmute themselves and make a suggestion for a solution that they feel they'd like us to test on this.
I don't see any hands raised, so I'm going to ask one question. Looking
Okay.
at this, why is coal going up in 2060?
2060, this
Yeah,
little bump here.
yeah.
Well, there's there this is the projected scenario that we are on right now.
Okay.
Right now, um, this clean energy is growing, but without more international solutions to bring clean energy to wider swaths of people, we're going to keep growing coal.
Okay.
So, as we propose some of these solutions, um, some of these levers that we flip may see those energy solutions going up.
Okay. Well, it looks
So,
like Carolyn has a question or would like to see what would happen with one of the changes.
okay.
Yeah, hi. I'd like to see what would happen if we looked over at methane and other gases. If people were to, say, cut their red meat consumption by 50%.
If we could reduce methane by 50%,
Yeah,
okay. Well, next to the methane tab, you see this all changed, and we can look here and plug in a number right here to reduce methane 50%. And I think I need to put a negative sign above that to reduce it. And what do you think is going to happen
well, I hope the
to
number flattens a bit, I guess. But I mean, I know that the consumption of red meat is, at least in the food world, is a major contributor
Mhm.
to
Right,
climate change.
right. So cows, agriculture, natural gas drilling, and
Yes.
waste. Um, this does consider other gases also. They've built in nitrous oxide, which comes from fertilizers, and F gases that are used in industry and consumer goods like air conditioners. So if we were able to reduce all of those and reduce the methane and other gases, let's take a look and see what that will do. Okay, so that would really have a impact of reducing us 0.2 degrees Celsius, which is fair. If you look over to the right and think about the impacts of being able to bring our scenario down to having that little of those methane gases in the atmosphere, it's a significant decrease. So the blue line that you see is the current scenario with the methane gas figured in, and the black line is still our business as usual kind of scenario. So that does help. Um, so
And I think that my understanding is that there are a lot of fairly easy ways, like doing more capping on natural gas drilling and fixing leaks in pipes and stuff like that. That it wouldn't. That I think
right.
would be huge disruptors.
Eric had a question in the chat, but Eric's question was if you think of methane as being one half of the gases, the nitrous oxide, the CFCs, that kind of thing. So it'd be only a 25% reduction. What would that do if we just used the new satellites that are locating the methane basically and shutting down methane?
So just click this number at 25% and assume that's methane only.
Right.
Okay. Then it's about half the reduction that it was before, down to 3.2 degrees
So
Celsius.
okay. So it'd be a straight half because, yeah, because the nitrous oxide, the other gases all come from industry and things like that. So it's a different control. Okay, Donovan.
I was more curious if we increased energy sources such as renewable and nuclear, and maybe also increased our carbon capture technology, how well that might help.
Okay. And what do you expect to see with that, Donovan, as we look at the global sources of primary energy? Do you expect that that mix of primary energy is going to change?
I'm not sure about the mix of primary energy when you take like the entire global energy use. But it would definitely, I mean, it would help with what we are emitting now and the power that we're burning through if more countries were to switch to mostly renewable and mostly nuclear. And then if we do have ways to have a carbon capture setup, which hopefully in the future is a viable option.
Okay. Well, let's take those one at a time. Carbon capture is under this technological reduction. And do you have parameters that you would like to test as far as carbon capture removal?
Let's go with just 25%. Let's see, out of curiosity.
Oh. So this one, I don't need the negative. Okay, so over to the right here, we're seeing the sources of net CO2 removal coming from a lot of different sources, not just a mechanical carbon capture machine or technology. So these this 0.2 degrees Celsius decrease in our future temperature increase is lowered, but that's from many different technological carbon factors. Let me scroll down here. Direct air capture and storage. We can use the detailed settings here. Let's remove this and just turn in these detailed settings and try putting, because when you say carbon capture, I'm assuming you're talking about technological carbon capture from...
Yeah, more like sequestration from the atmosphere currently.
Okay, so the kind of technology that's being worked on right now, tested. Okay, so let's put 25% here. And oh, now I think it wants, oh, there we go. Yeah. Oh, I think.
I don't think you need it up at the top anymore because that's dark. I think that might be just a leftover.
All right. So that takes us down to 3.2. So that's a little less effective than sequestering it at every different. Well, actually, that is the same, isn't it? It was 3.2 when we put 25% in up at the top. So with this direct air carbon capture and storage, if we are able to remove 25% of it and start getting funding this year, we'll eventually be able to start pulling some of that out. I do see on the net greenhouse gas emissions that there is a little divergence starting here from 2030, as early as 2030 from the main scenario, but it does stay quite similar even toward 2050. There's not a whole lot being pulled out of the atmosphere. Does anybody know why we might have that sort of delay in pulling carbon out of the air?
If we're not even pulling as much as what our current emissions would be, then it wouldn't be able to counteract the emissions fast enough.
Right. Very good. Yeah. And we don't really have the technology yet to bring carbon capture to market. And so it typically takes 15 to 30 years to actually invent something and bring it to scale across the world so that we'll be able to see some real impacts. And so let's look at the renewable energy and add that on to your solution. And as far as renewables, are you thinking of subsidizing renewables more than what the Inflation Reduction Act has so far?
I mean, that would be ideal, because I mean, the Inflation Reduction Act has been great, or at least sets great standards, better than where we're at, but they should definitely be increased.
Okay. Well, as I click on just a subsidy for renewables, it went down another 0.1% to 3.1. If we were to highly subsidize renewables, let's look at, this seems to be growing. So let's look at these lines as I do a replay. So without the renewables and with the renewables. Yeah, so not a whole lot of change. And part of that is our infrastructure. So just subsidizing renewables without adding some other benefits, I think is going to not be as effective, because renewable energy at this point can't be transmitted as quickly, and there isn't storage for it. So storage, there is storage, sorry about that. But, without expanding on the storage of renewables, we're still stuck with not getting as much solar when there's no sun, and as much wind energy when there's not wind. And so
but Deb, we're also increasing the renewables tremendously on this chart, but we haven't lowered any of the others. We've just increased the amount of electricity that we're producing. If you look like at 2020, we were producing 600, whatever an X joule is, and now At 2100, we're up to 2100 exajoules. So it strikes me that we're not reducing the coal and the oil, but we are just increasing electricity in general.
Right. And so Donovan had one more solution he wanted to test. And before we reduce use of other things, maybe we should look at the nuclear option. Is that okay with everyone?
Sure, go for it.
So Donovan, how much are you thinking we should subsidize and expand nuclear energy?
If we can go like just 50% to see what that does, just curious, just out of curiosity. I'm not sure what that would be in terms of pricing.
Okay. Yeah, nuclear basically is looking for a kilowatt hour subsidy for nuclear. Nuclear is one of the more expensive energies. It also gives us an option to have a breakthrough in cost reduction for nuclear energy. If you wanted to take advantage of either of those levers.
Yeah, if we could do the nuclear tax subsidy, if you could put it like, are you able to move the slider bar or just?
Yeah.
If you just want to put it like like halfway in between, and then
Okay.
maybe like 20% for the breakthrough.
Okay. So subsidize would be a subsidy of 4 cents per kilowatt hour. And then what did you say about the breakthrough?
Maybe like 20%.
Okay. Okay, so we can see that nuclear really grows with that selection, starting in around 2032. I think most of you know that nuclear power plants take a considerable amount of time, typically close to 10 years to get them producing. And so once they're producing, that keeps growing, and it does reduce our temperature increase to just 3 degrees by 2100. And by 2050, it's a similar amount. So it just stays level across there. It doesn't keep reducing greenhouse gas emissions. And what we see up here is that this has grown as far as our energy usage goes. But let's take a look at what
Can we
happened.
do something else? Can we keep it at the 1000, but reduce fossil fuels down to next to zero? We're at the year 2100 out here. So if we start, if we might have to increase renewables to keep it at the 2100, okay? But I think we're going to need more energy as the world continues. But if
Okay.
we now start dropping the coal and oil and increasing renewables, leaving it at the 1000, what does that do to it?
So how do you want to drop coal and oil, Nikki? Just by shutting it down, shutting down plants, limiting?
Basically phasing it out, let's see, we got 20% a century, a decade, or I would love to see it shut down tomorrow, but we're not ready for that. But
Right.
but reducing both the coal and the oil down to basically zero by 2100. I mean, even Saudi Arabia is going with solar at this point. They don't use their own coal. You know, Texas isn't using its own oil. It's like they go with it. They have the solar and the wind turbines. It's the northern fools that are using it.
You're suggesting that we reduce coal utilization by 100% by 2100. Is that
Right.
right?
Yeah.
Okay. All
Or
right.
even if you want to leave it at 90%, you know, so that, you know.
Well, you see here in our coal primary energy demand, it has disappeared by 2033. So to up here on the top, to completely stop coal utilization, we're going to have to
Can we do it as
stop.
a phase out, or is it not possible to do it as a phase out?
Reduction in coal utilization to start in 2024. So if I could change the year that we started limiting it, but it would also phase it out if we just reduced new coal infrastructure up here.
And let the
So,
old mines go out.
right. So why don't we say across the world, everyone agrees to stop building at least half of the coal infrastructure in the next what, 10 years?
Be realistic, say 20.
Okay. Coal tax subsidy stop year, that's a different thing. So we are still offering tax subsidies to coal. Reduction, yeah, well, we could just say that 50% happens now. And oh, here's a value that has to be, okay, so I guess I have to stop a subsidy if we're going to reduce the new coal infrastructure.
I would say if we're going to stop the new infrastructure in 20 years, we should stop the subsidies in 20 years.
Okay, so by 2044.
Right.
Okay, so that takes us down to 2.6 degrees with just those solutions. And you can see what it's done to the energy mix over here. Nuclear is bigger. It's not the tiny little line that it was before. This pink bioenergy is still viable. The renewables, well, let's see if renewables have expanded at all if we're pulling out. No, they're just not growing because we've already grown them.
Yeah, you can see that it went down from 1,000 to about 920, 950, somewhere in there, you know.
And then gas and oil are still as big of a part of the energy mix as what we have in renewables here. So together, they are making about the same amount there. So who's got some more ideas?
Nobody has their hand up, so.
Okay.
Well, with lowering coal, could we also try like lowering oil at the same time?
Mm-hmm.
Or
Okay, so our oil option is to tax oil. Or I think we could also stop subsidizing oil. Yeah. So right now it looks like we could either tax oil or stop the subsidies, reduce new oil infrastructure with regulations, or reduction in oil utilization. So let's just reduce the subsidy on oil. Does that sound good?
Yeah, it went down.
Yeah.
Okay, and then I have two people with questions.
Okay, good.
Do you want the questions?
Yeah.
Catherine, you were up there first.
Hi, everyone. I was curious whether there's a way to examine whether changes in agricultural practices can be made in the model, such not just reducing the emissions from meat production, but things like cover cropping or perennial crops or no-till. Is there a way to play with those parameters, or is it kind of all built into that methane?
Yeah, food is up here in the land, food and industry emissions. And so some of the methods that were first offered did include gases, like gases from cows and gases from food waste and those sort of things. I'm not sure if cover crops are in here. So what we have here is assuming a 30% that we reduce food waste 30% by 2100. I think we can do better than that. We can also increase the amount of that we would reduce. Let's see, food from animals is set at 30% of the diet by 2100. We could increase that.
Or decrease it. You want to get rid of the animals.
Yeah, you're right. Thank you, Nikki. Does that sound like something that you're talking about, Catherine? Is that the lever?
No, I'm kind of talking about if we moved away from conventional agricultural practices, but it seems like maybe that would be built into more of the maybe afforestation or
I agree
increases in
with you,
changes in land
Catherine.
use, that type of thing.
Part of what you're talking about is regenerative farming. And that reduces the need for fertilizer, which would reduce the need for the nitrous oxide and it getting into the air, that kind of thing, and into the water. And so, and I don't think this is taking that into consideration when it's talking about. I mean, I might when it reduces from the food from animals, but it's not talking. It doesn't seem to be talking about how you cultivate the food.
Okay, let me just check here and see if there is a regenerative farming solution yet. And it It is not coming up.
Okay. Yeah, I just was curious.
Yeah, I know that's on a lot of people's concern though. So I think we can expect that that will be available on here at some point.
Just a second question. So if I wanted to incorporate this into one of my classes, are there already exercises or sort of a workflow for that available somewhere? And you know,
Yes.
so you're not starting from scratch?
Yes, and actually, if you were to talk to your instructor about it,
I'm the
oh,
instructor.
wait, you're a teacher. Okay, there are classroom assignments that you can give your students. Like Alan gave his students the assignment to write a paper using AI. You can give your students an assignment for whatever outcome you're looking for to use the En-ROADS tool to show how they got to that. And once you're on the simulator, and we'll supply the link to the simulator in a minute, but once you're on the simulator, if you just go up here to En-ROADS, it will take you to the En-ROADS website, the Climate Interactive website, and then here's where we explore the simulator. But this talks about what is En-ROADS, and then as I scroll down, there are other ways that you can use En-ROADS. And so down, I believe here, yeah, to find the event that's right for you, we'll let you go to the different ways that you can use En-ROADS.
Okay.
Just looking, yeah, so let me just click on that one. And I think that's going to take us to the, yeah, so there's a game that you can play. The game takes actually about 2 hours to really do it the way it's intended. And so if you have a class that lasts that long, or if you can create a smaller version of it. But here's the En-ROADS guided assignment. And so if you click on this section, it'll take you there. And the fantastic thing about En-ROADS is everything is free, and all of the resources are there for you to be able to do that. So
Perfect. Yeah, that's what I was looking for. Thank you.
Sure, you're welcome.
Okay, Kate, you're next then.
I kind of withdrew my hand, but first of all, I wanted to thank Deb for doing this training and teaching us. It's kind of confusing. So when you ask questions, it's kind of like, what do I want to know? But I think, like Catherine, a lot of education of us, of the US, would help in, people saying, well, methane doesn't cause any problems, and, things like that, or the urine from the cows, that goes into our table water and things like that. It seems like with the renewables, you could sort of dovetail. So you have renewables, but you also have the reduction of methane. You also have the reduction of coal, oil, and gas, which you're helping us with this graph. I really appreciate it. So I guess I don't really have a question. Well, yes. How could we take subsidies away from the oil and gas and coal people? That would help them stop mining, I think.
Right. One way, like Nikki mentioned in the beginning, is that I'm a member of Citizens Climate Lobby. And one of the things that we advocate for is putting a price on carbon, because putting a price on carbon makes any kind of fossil fuel energies more expensive and just drives down the demand for them naturally. Now, a carbon price has its challenges because it's not something that we can just do as citizens. But I know, Catherine, that I've gotten a lot of emails from you about things like electrification and energy efficiency and electric cars and electrifying the bus systems with the schools and things like that. And we haven't played with any of those levers yet.
Do you have those levers in here?
Yeah. So here, under the transport, we can increase energy efficiency for all of our transport, airplanes, cars, buses, or we can expand on electrification, buildings and industry. We can add energy efficiency. We can also add electrification. And this is the area where my husband is really focused on this kind of stuff. And we're in Michigan, we're making some great strides in being able to electrify things. So if we look at, and Nikki, I think we're getting close to
Your time.
okay. So if I'm just going to flip these energy efficiency and electrification levers that would actually take us closer to these would actually expand more on the electrification subsidies and those kind of things, even more so than what the Inflation Reduction Act does here in our country. But it would help us simulate more if we're able to get our infrastructure built so that we can transmit that energy and store energy more effective. Another thing nobody's asked about is this new zero carbon technology. And those are things that haven't been invented yet and will take a while to get to us, to get them to scale to be more effective. Down here is the carbon price. And once we've kept coal in the ground, basically, like we've done there, and we've reduced the oil like we have here, there's really not a lot we can do. But this gas, we all know that natural gas is very much a lot of methane. And so pulling this out would also help us. It still, is not a clean energy. It's a fossil gas. And so pulling more of that out, we're down to 2.1. And if we put a carbon price on, we're going to get down below that 2 degrees. We can also, one of the things that CCL advocates for is planting more trees and having healthy forests. And that when we do that, we're removing the natural carbon from the air. And so that takes us down to 1.8 degrees, which is a fairly realistic number of where we can get in the future. I think most of you have heard the science that we may be past the point of being able to get to 1.5 degrees. It still is a hope for the world that we will get there. But I would just like to also show you some of these other things that we have up here. We have the marginal cost of electricity production, and how these kind of spaghetti models show us how the costs of things are going to change as we implement policies like this. Does anyone have any other questions?
Yeah, we got 2 more questions here. Elise, you're up.
Yeah, I just had a quick question regarding when you look at things like afforestation and deforestation, you say they're constantly updating these projections. Are they looking at rates of forest fires and how that's going to likely increase? Are they making any kinds of projections, not just based on any policies that have recently been implemented, but also the science of what's been changing that way as well?
Yes, and unfortunately, because so many of the forests are burning, what we're replacing those trees with is new growth. And it really takes a long time for a tree to mature enough to be able to get to the point that it can start removing carbon from the atmosphere. And so we're looking at the importance of keeping forests healthy by, trimming them out and cutting out the old growth that allows the forest fires to spread so out of control. But we can look at a number here to really decrease the amount of trees and the forest degradation to allow the trees to keep removing the carbon from the atmosphere the way that they have been. The Amazon forest is reducing in size, and we're just having those kind of things replacing the Amazon forest with cow farming is just something that we need world leaders to get on board with. And these kind of presentations given to those world leaders are helping people understand the economic impacts for their country. It's not all about the short-term gain of, getting cows on their land and burning down those trees. So those kind of things are figured in here. And every place where there is one of these little drop downs that we can look further, there's more information. And in here, there are examples of things that can be changed or considered when people are making these decisions. Reducing forests, reducing deforestation is part of a multi-pronged effect. The key dynamics are here. There's potential co-benefits to reducing the deforestation.
So as an educational tool, these little side notes, like I think it was Catherine was asking about teaching. So these little side notes would really be the educational portion of it. This is what's being considered. This is what you need to know about this when we make these changes. Like here,
right.
Year to
So
date.
Wanted to give her students an assignment to find an equitable climate solution that could be implemented by 2050 to
And this also
Provide-
talks about social justice, though, which is nice.
Yeah, we are definitely all about that in our coalition. And so the fact that these equity considerations have been considered, they're in everywhere, even in our big carbon price, there's equity considerations.
Okay.
So again, I'm clicking on the 3 dots that are right next to carbon price. It brings this up, and then you just have to go to this information button, and it brings this. There are a lot of countries around the world now that do have a carbon price, and those are, making an impact in the bringing that initial 3.3 degrees that it is without this solution. So the benefits and the equity consideration for a carbon price is that as we make fossil fuels more expensive, it's not really equitable to poor people. And even though they'll be getting the cleaner air, which will help them, it is difficult to imagine that it could be a benefit unless we take that money and give it back to the people. And so that there's now a way in En-ROADS that you can determine where the money from a carbon price goes. So.
Okay. So we have 2 more questions here. Tim?
Okay.
Well, what I have to say actually follows directly from what Elise said, but there's been a lot of intervening stuff in the meantime. And the question had to do with how rapidly En-ROADS can catch up with the latest research, and specifically with respect to afforestation. In today's news, and this is today, there is a report on an article in Science saying, quote, by one of the lead authors, we're not saying trees are bad, we're saying trees have a part to play, but we need to think about how they affect the whole Earth system. Trees are not a substitute for carrying on as we are with increasing renewable energy. We need to cut emissions at the same time. So the point of the article is that apparently in the Science article, afforestation research is suggesting it's more complicated than we have thought up until now.
Well, also, I think it might be relating to the fact that a lot of people are buying into this whole concept of net zero, and they're paying for their carbon by planting trees. But the carbon that you're using today the trees are not going to be removing for 50 years. So I think part of that is relating to that whole concept of you can buy your way out of it. Donovan?
I just had a question. So with everything that En-ROADS includes in their data, do you know if they also take things into consideration like positive feedback, such as like ice melt and permafrost melt, or wildfires? Like, do they take those things that a lot of scientific literature does not take into consideration when they talk about global warming? Or is that something that's also possibly left out here?
They do take a lot of that into consideration. And just like Tim said, every day there's new information about more that's going on. We have found out that as the ice caps melt, the oceans are also warming and acidifying. And so those kind of impacts do get built in here as far as the projections where we're going. And there is a graph for sea level rise here that takes into consideration where, so if we take this off, we can see that we expect sea level rise to be at 0.7 meters. And then, things like putting a big solution into effect can lower that impact. And so the melting polar ice caps are part of the sea level rise. And if I go to this information button, I can see up here about impacts like you were just asking about. Was it the ocean acidification or?
I mentioned like ice melt or permafrost melt, but also ocean acidification, if that.
Yeah, so restored assumption sliders for methane and emissions from biological activity. So yeah, that's where those would be factored in. Affect the temperature on methane emissions from permafrost and clathrates and temperature threshold for permafrost. So this should take me to a link. And yeah, so that's how you would find out more information about what they have factored in. And each of the upgrades have a little
Right there.
workshop that explains to people exactly all the parameters around those upgrades.
All right. Yeah, that's great to know. Thank you.
Tim?
Yeah, relating to his question, Sue, I'm sorry, Deb, could you go back to the search and search for the phrase tipping point? Tipping point. Tipping points are now increasingly gaining scientifically legitimate, scientific legitimacy as a
Nope, not finding it.
a good put a hyphen in there between. Let's see if that makes a difference. Take out the space. Okay.
Put in AMOC.
No. Okay. So that's interesting because tipping points are now pretty much a legitimate scientific concept that's well researched and understood. So it's interesting it's not in there.
But there are tipping points, I believe, that are figured in as far as the rate of increase of the greenhouse gas emissions. Because they do increase faster once we reach those tipping points, right?
The tipping point doesn't necessarily say it's going to go faster. It just says that it's going to go and not stop.
To have what we need by 2050, we really need to implement a whole lot more. And so, the thing I like about En-ROADS is that we just need to be doing the all above ASAP or yesterday. I think this shows this well.
Okay. I'd like to sort of end this with a comment from Veronica. I don't know if you saw it in the chat. She said, "Thank you. This is a great resource. It's given me great ideas how to communicate about climate in a way that can be understood by many." Thank you.
Thanks everyone for coming.